Hey guys, I'm back with new videos. In this video, let us learn about yet another algorithm for classification, known as the KNN algorithm or the K nearest neighbors algorithm. Now, KNN algorithm is a non-parametric algorithm. Simply, so if you are unable to recall what a non-parametric method was, I discussed that in one of the starting videos of this series. The link for that video can be found down below. Now let us take the case where we have only two input variables and a y is basically a binary class and it can only have one of the two possible values, either 0 or a 1. Now let us represent the value of 0 with a blue star and the value 1 with a yellow star. So let us draw a scatter plot. Even on the screen is a scatter plot. The main aim again is to segregate the two classes of point using a boundary, so that for a new data point we can classify it easily into the correct side to which it should belong. So let us say the new data point is represented by a question mark and it is located somewhat around here. So the question that must arise in our minds is that to which class this data point should go to. Should it go to class 0 represented by a blue star, or should it go to a class of 1 represented by a yellow star? So there must be some criteria or some condition based on which the algorithm under study should be able to classify the new data point to the correct class. So let us see how we can do that using the KNN algorithm. So let us assume the value of k as 8. Now we are interested in the 8 nearest neighbors in the vicinity of this new data point. That is represented by a question mark. So the 8 points that are in the vicinity of this question mark are, we have 5 blue stars and 3 yellow stars. So once we have got the 8 nearest neighbors to our new data point, we can confine all these points within a boundary. For now, let us assume that we have circular boundary. So now the algorithm will only focus on the points that lie within the circular boundary. So it will count the number of points that represent class 1, which in this case is 3, and the number of points or your number of blue stars that represent a class of 0. And whatever class has more number of points within the boundary, that will be the class to which the new data point, which is represented by a question mark, will go. So in this case, the question mark, which is the new data point, will go to the class of zeros represented by blue stars. And this is how it will decide that to which class the new data point should get assigned to. Here also to predict for a collection of new data points. So suppose we had multiple such question marks looking for getting a class. Okay, so for that collection of new data points, the algorithm will iteratively repeat the process over and over again to classify these points to the correct class to which they should belong. Now the thing we need to understand is how the KNN algorithm separates the two classes of points that we are having in our dataset. So how does it create that decisive demarcation boundary? So let us see that. So now, instead of assuming, as in the previous case, a single data point, let us assume we have a collection of such points, okay? A collection of such question marks that we want to classify. So now our goal is to determine the class for each of the point that is there in the collection of the new data points. So now after many iterations, the collection of new points, what will happen is that we will get this kind of decision demarcation boundary that will segregate both the classes of points from each other. So on the basis of this wavy demarcation boundary, we can say that if a point lies to this side of the boundary, which is this side, that is above this wavy boundary, then it belongs to a class of 1 represented by yellow stars. Otherwise, if it lies below this wavy decision boundary, then it belongs to a class of 0 represented by blue stars. Now the boundary that we got in case of a logistic regression had an equation which we discussed in that video. And I told you in that video that it is known as the sigmoid function. But the boundary that you get after classifying a collection of new points, which in this case is wavy in nature, okay? So once you try to classify a bunch of unknown points, you will get this kind of demarcation boundary which is wavy, okay? Or you can say something that you cannot determine or give an equation for. So it is a rather complex boundary. Now one thing to take note of is that the KNN algorithm gives us a boundary after classifying all the new data points. So this boundary is obtained once you have classified all the data points want to give a class for, and this boundary is much more self-adapting and bends in such a way that it fits through your points as closely as possible. So that is one of the advantages over the classification method that we had discussed in one of the previous videos. So now let us discuss about one of the most important subtopics here on finding the most optimal value of k for our algorithm. Now the key thing is that to get an optimal value of k is to reduce the error component as much as possible. So now let us discuss about a very important concept that will help us in determining the optimal value of k, and the concept is known as bias variance trade-off, which we'll see in the next video. So if you like the video, do subscribe to the channel, share the channel with your friends and colleagues, hit the bell icon for all the upcoming uploads, and I will see you guys in the very next video.